Right, okay, welcome back to the next video. I've tried to sort out some of the sound issues by using a different microphone, so hopefully this will be a little bit better than that previous couple of videos. So what we're looking at this time is the concept of gravitational potential energy. Now you will have come across this term before, back when you talked about different energy stores. So you probably know that gravitational potential energy is just the energy that an object has got, basically because of how high up it is. Now the official definition for gravitational potential energy is the energy an object has due to its position in the Earth's gravitational field. So I'll just write that down. Okay, so there's our definition for gravitational potential energy. That term gravitational field just really means the area around the Earth or around any planet where an object will experience the force of gravity. You know that the force of gravity attracts everything down towards the Earth, and the area where that force is felt, that is called the gravitational field. Now let's have a think about what our formula is going to be for gravitational potential energy. Um, there are three things actually that you have to multiply together to get gravitational potential energy. Now I'm just going to have to be careful because of space here. So gravitational potential energy equals, let's think of the three things that will affect how much energy an object has, or how much gravitational potential energy an object has. The first thing is its mass. So the bigger the mass, the bigger the gravitational potential energy. Okay, multiplied then by the strength of gravity. Now you might remember that that is known as gravitational field strength. We did actually mention that a couple of videos ago. And then multiply by the height, how high up you've moved the object. Okay, so those are our three things being multiplied together. Let's think about the units here. Gravitational potential energy we know is measured in joules because it's energy. You're probably getting quite used to that by now. Mass measured in kilograms. Hopefully you can remember. Yep, that's right. I'm sure you just said newtons per kilogram, and height measured in meters. So those are our units. If we want our formula in symbols, which again, you know my thoughts on that, I don't recommend putting it in symbols in the exam. The only advantage is it saves time. The reason you just got to be careful is gravitational potential energy is given the symbol capital E with a P, a subscript P. So it stands for potential energy. But obviously it's very easy to forget that and to just write GPE or EG or GE. And if you do that, you do run the risk of not picking up these marks. So you can see there, that is how you would write it in symbols. One final thing to mention on this little bit, which you may remember, is this gravitational field strength on Earth. Hopefully you can remember that G is 9.8 newtons per kilogram. Now they should give that to you in the question, but it's always worth learning it just in case they don't. Okay, right, let's have a look then at some examples. Okay, so for example number one, we're going to talk about this parrot. Okay, I'll put him over here actually. So a bird has a mass of 2 kilograms and flies at a height of 200 meters. Find its gravitational potential energy. Okay. Right, so first step then, as always, is going to be to write out my formula. So I know it's a lot to write out, but I'm just going to do that again first. Okay, there we go, then there's my formula. Right, now all I need to do then is put the numbers in. So we're trying to find gravitational potential energy equals, well, mass is 2 kilograms times gravitational field strength, which we're on Earth, we're assuming that the bird is flying above the Earth, 9.8, times by the height, which is 200. Okay, and so then we would get our calculator. We would type in 2 times 9.8 times 200, and what that gives me then is an answer of 3,920 joules. Okay, and there's my answer. Okay, we need a bit more room for the next example. So for the next one, we are going to think about a helicopter. So here's my helicopter, and we're going to try and work out something about the helicopter, but this time we're not trying to find the energy. In fact, this time we're already given the energy. So for question 2 here then, we're going to say that a helicopter has, and we're being told the amount of energy it's got, and we're going to be told that it's got 4.9 mJ, we'll talk about that in a second, of gravitational potential energy. And I'm also being told that the helicopter flies at a height of 100 meters. And the question is to find its mass. Okay, well, first step, hopefully you're getting used to this by now. First step is to write out the formula. So here we go again. Okay, there we go again. So there's our formula. Okay, let's substitute in then the numbers that we know. So gravitational potential energy, we do know, look, it's up here, but we have got to be careful. 4.9, the capital M there stands for mega. So 4.9 megajoules, I haven't left myself much room here, but 4.9 megajoules, mega, if you remember, means multiplied by a million. So that is 4,900,000 joules. Now, for those of you confident with maths and familiar with standard form, mega just means times 10 to the power of 6. So you could write this as 4.9 times 10 to the power of 6 joules. If you don't know what I'm talking about or you're not happy with that, this way hopefully you can understand. Multiplied by a million gives me my number of joules. So there's my energy. So this is going to be 4,900,000 joules. Equals mass. Well, that's what I'm trying to find. Gravitational field strength, again, we're assuming we're flying above the Earth, that's 9.8, times the height, which is 100. Okay, now next step is to look at this, because there are 4 things in this equation, not just 3, we've got to look at simplifying this a bit. Well, luckily over here, look, 9.8 times 100, we can simplify that. So on this side, I've still got my 4,900,000 equals mass times, well, 9.8 times 100, that's 980. So all I've done is multiply these two together. All right, then, using a bit of maths, hopefully we know that mass now equals 4,900,000. I'm dividing both sides of this equation by 980. If you're not quite sure, by all means pause the video, take a bit of time to look back, make sure you understand it. And if I do that calculation, that gives me an answer of 5,000 kilograms. And just a general tip here, it is always worth just having a look at your answer to make sure it's sensible. 5,000 kilograms, that's 5 tons for a helicopter. That's quite sensible. If you got an answer of 5 kilograms for a helicopter, that's not very sensible. If you got an answer of 5 billion kilograms, again, not very sensible. So always just look at what you've got, make sure it's a sensible answer for whatever it is you're looking for. All right, that's about it for gravitational potential energy. Next video we'll be talking about kinetic energy, but for now, keep working hard, and I will speak to you soon.